We are at episode 13 of programming our game here. The last time we left off, we were working on how we were going to build our GUI for our asset tool. I had said on that stream that I would work on the tool a little bit independently of the stream just because we were spending a lot of time working through some things that were not necessarily related to the NES, and nobody objected to that idea, so I figured let me do that so we can get some things actually happening, and we can talk about what we need the tool to do. We can build some stuff related to color checking and stuff like that. We can also, I'm hoping we'll be able to get an export of one of the existing images that we already have just to confirm that we're doing that the right way, independently of using something like YYCHR. And yeah, and so let's get to that. Let's start by looking at what I've built so far. So I went back and I changed the list. I changed it a little bit from where it was before. So previously, you couldn't check the list item selections until the end, and that was because of the way that it was building up the list items in the GUI control for lists, where it was calculating the position of the list item in the list here in this list end call. And what I discovered is because I was using a fixed list height for the items, I could pretty easily calculate the position of each list item within the context of the list itself. Now, the other thing I did was I changed some of these components to have their X and Y be relative to the parent context, which simplifies this checking of the list items, as well as another control that we'll get to in a second. But in addition to that, I also, for the list itself, added an additional layer of rendering. And the reason that I did that is because if you think about the way lists typically work, they have a space that, like in here, right? They have a space where they render their content, and sometimes that content is truncated, sometimes that content is redrawn and wrapped. So if you look at something like this, it's squashing it as best as it can, and eventually it adds a scroll bar. And that area in here is a scrollable canvas, essentially, right? That contains the graphical data for that tree that's being displayed. Well, similarly, I wanted to be able to display a list of items and have the items be properly clipped if the names went too long. So rather than trying to do the clipping as the drawing was occurring, what it was doing instead was it is using this list buffer that gets created as the destination buffer for the list itself, and then rendering that down to the background. So if we go, I'll be referencing this again just so that we're clear. So, you know, if this is our background and this is our list, and then we have all of our list items off this control node, right? These are all our list items. Instead of using the buffer that's here that goes to the display, instead we have a smaller buffer that these items render into, and then that parent gets rendered to the background. So that allows us to do things like what I was talking about. So let's go to the control here. So you can see we've got these items. That's looking relatively normal. Although, you know, I have to say this this line is too thick. I wonder if it's not overlapping properly, but that's not that important. What I wanted to do is say, okay, so if we change the list so that it's a lot more narrow, so we change the width, and let's say we make it 50 instead of 150. When we draw, you're going to see the text is truncated instead of drawing off the side, or the list item being off the side and going over into the background. So that's what I wanted that to do. So I'm happy with that. And then, like I said, the list items are now being, you're checking if they're clicked when you're actually putting the item into the list. So what it's doing is it's entering these current files that are coming back from the parent folder. So if we go to, we can close this, we don't need this. If we go to this folder, we can see that there's this PNG and that PNG. And in the Win32 layer, I added to this code here that we were using to find the files in the parent folder. I added the ability to add file filters. So right now it's just looking for all .png files. Eventually we could add other file extensions, and if we needed to, we could potentially make that configurable. But for now, that was all I was interested in, because what I'd like to be able to do is take that PNG and export it. So now that we have that working, I said, okay, well, now when we actually select this, I want the image that's selected to be drawn here, and I want the NES palette to show up. So when you click on a list item, it triggers that the file was selected, and I'll leave this here just to show it in the print statement before I take it out. It's going to toggle image is visible, which actually this should be really maybe image selected. And then what that does is it loads an image, it loads the width and height of the image, and then this little toggle thing here, this isn't the best way to do it. This is related to the image ID, if it's unique, not reloading the image. So we're trying to be mindful of the fact that we don't want to keep reloading the image every time we render that image control, which I created. So you have the ability to put an image at a location on the screen. I didn't want that to have to reload the image every time. So as long as the ID is the same, it will continue to use the same image that was loaded into memory until that node is pruned, which will happen when on a refresh that ID isn't used in the node control tree. The problem with that is that when we go to change the file, if the ID is the same, it doesn't refresh the control, which technically is right, but we do want it to refresh the control. So what I'm just using is an exclusive OR on the first bit of the image ID to toggle it between 4001 and 4000, right? Because that one bit with the exclusive OR on 1 flip-flops back and forth to 0 and 1. And so by doing that, it creates and destroys the node as we toggle between images that we're going to draw. So it draws the image with this command, and then it uses the color selector, which is another control that I created, which is just going to render the NES palette within a space that's given. The buttons, I added the ability to provide an anchor style to the buttons. So the idea of the anchor is if we are looking at a window and I have a button that I put at the bottom right, like I've explained before, when I go to expand that window, the button should move equally in that direction or that direction, depending on how the anchoring is defined for the button. So this is a bit field, essentially. If we go to the definition of these anchor styles, you have 0 for no anchor, 1, 2, 4, and 8 for left, right, top, and bottom, and you're just using a bitwise OR to combine the anchoring. Now, obviously doing a left and right anchoring probably doesn't make sense, but you know, you could say I want to anchor right and anchor bottom, and then it'll stay in that bottom corner as you expand out. So if we run this again, when I expand the window, it doesn't redraw dynamically, but as I expand it, you can see that button followed the corner, and that wouldn't have happened before. Before, it would have stayed in the position it was in, like this is doing. I have to implement the anchoring for that, and I'll show you what that is in a second. But you can see it's moving along. So that's pretty cool that that's working now. And then let's see. Yeah, and then the color selector, which is exactly what it sounds like. It allows you to select colors. It's specifically using the palette from the NES, and that palette is stored in an array of RGB values here. That palette took that from NESDev, based on the palette RGB definitions that they had there. And where is it? Color selector, not control. So the color selector, when it renders, it's just rendering a grid of the colors. And it's a pretty simple control. About the only thing that's interesting about it is that it's using the position of the mouse to determine if you've selected one of the colors from the palette, and it'll return that color. Otherwise, it returns back the current color that was selected in the control. So if you remember, that's tied to me selecting an image. So when I select the image, I get the PNG that I selected in the list, and then it's just flipping back and forth between those images. You can see the print here saying that it that it selected that PNG. And then if I click on the palette, I get that color change registered here. So that's pretty cool that that's all working. What I want to do today, I want it to warn us if it detects that there are too many colors included in the image. Because, at least to start out with, we're gonna, assume that our sprite can only be, or our images can only have 4 colors. There are rules where that can be changed and broken because, over the span of 4x4 tile chunks, the colors can be different if it's a background, or the palette of 4 colors can be different if it's a background. It's for sprites especially, you're pretty much set on your 4 colors unless you're using multiple sprites, and then the multiple sprites can reference the 4 colors of 4. And we can see that if we go back to the shooter game here and you look at the PPU viewer, you can see we have these different palettes, and each sprite can use the different palettes. If I right click on this part of the PPU, it will show the different palette, or the image data with the different palette loaded. So that's kind of cool. But okay, so obviously these images are okay. We're gonna try and take something real quick, and I'm going to run it into Photoshop and make sure that it has more than 4 colors, and we'll test on that as well. So let's do that real quick. I should have picked something ahead of time so I didn't have to go searching for it. Let's see, what can we use? Do we have anything right here? I assume these are sprites from, yeah, so those are sprites for the NES. This might be, let's see, this was some pixel art I was messing around with. How come it didn't get added to that? Thought I'd be able to just right click and... Alright, So let's see. This let me take the grid off. Show. Oh, okay. It's because we're down at the pixel level. Yeah, this definitely. If we go to indexed. So the color table that I have loaded into here is an NES color table, which makes it convenient so you can kind of see what that's going to look like when you change the color scheme over to the NES. It'll do a sort of best match. I mean, it looks kind of terrible by comparison to that green is not what I was going for here originally. So let's see if I can do gray real quick. What doesn't it? Oh, because it's trying to do gradient. Oh, come on. Just keep making all these changes to this, and it is not for the better. Here we go. Do a darker color. Looks like that's the darkest it's gonna. It's the other reason why something like Photoshop is not great for pixel art with very specific palettes, at least not that I've seen, because what you end up with is you end up with exactly what I'm doing, where you're like just kind of hunting for colors. Now, admittedly, I am not an expert when it comes to Photoshop, so in fact, I barely ever use it, but it is, for other things, much more convenient. I'm just going to leave this because it really, it doesn't matter. All right, so, oh, except that I didn't really want to save the original like that. Oh, well. Is that the original? Is that what that looked like? Okay. Let me save that, and then save that, and we'll call that rack NES. So now we've got the indexed image. And the idea would be, hopefully, that we don't have to use Photoshop to do this moving forward, because we'll have a tool that will do what we need to, you know, within reason. I'm not saying that we wouldn't need to use Photoshop or GIMP for certain things that are more complex, but for simple things. All right, so that's drawing it, and it's huge because it wasn't meant to be, you know, a tiny thing in the NES originally. But the point is also, we want something that's got a lot of color to it, so we can look at the image data that's in the PNG and find the number of colors and have it issue a warning essentially on screen that there are too many colors for that to be exported, at least in the most sort of simplistic way right now. All right, so how are we going to do that? I don't know. The laziest sort of way that I would do that normally is you'd have some sort of like dictionary code or so, you know, that you'd reference in C#, where each color would go into the dictionary as a key, and then from that you'd then say, then you'd be able to count how many new keys you have in the dictionary, and then, you know, we could probably do that. We could do that in a less lazy, sort of less inefficient way. So basically the idea would be, we'd take a look at the image, and we'd have an empty, it wouldn't be empty, it would be an array initialized to nothing, and we'd have a, you know, color count to some color, it's to some amount. And then what we do is we say, okay, we have a color. Based on the color count, let's look at the color list. You know, is it in there? We could even, You know what we could do? That would be even better. We know that we're only going to ever have the limited number, the 64 colors in the NES. So what we can do is we could even make it a 64-bit value. Yeah, I kind of like that. So what we could do is it's a 64-bit value, right? We say it's 64 bits, and if we get a color, we mark the bit, right? And when we increase the color count, and we set it to be 1, and then from there we can count the number of bits that are set. We don't have to increase the color count. We just keep setting the bit accordingly, and then when we're done, like I said, we count the bits, and if there are more than, you know, however many bits set, we don't have to count them all. We just want to see how many there are, and then we can indicate, yep, we've exceeded our 4 colors. So, and that would be a pretty straightforward thing to implement. So let's do that. So in Windows, it would be an unsigned long, I believe, for 64 bits. Do I want to make an alias? I don't know. Probably do for cross-platform type stuff, but yeah, let's do that. Call it UN64. Eventually, we should probably do this for most of our types. I believe, and I always mess up the order of what's what. Not that it isn't logical the way it is, it's just for some reason in my brain, I always have that blockage. So the cool thing about this is we can say, okay, color count is 0. So by doing this, or let's call it color map. By doing this, all we have to do to initialize this, instead of iterating through an array or something like that, is we can just set it to 0. So when we come into here, right, we've loaded the image, we say color map is equal to 0, we've reinitialized it. Now what we want to do is we want to iterate, not using I, because we've already used that here. Int j is less than j image width times image height plus j. All right, so we've got our set of our width and height. So now image indexed I, no, just j. So actually, let me talk about this for a second. So I added this to the Tiger structure. I've settled on Tiger because it's tiny graphics, right? So graph, I don't know. That's what we're going to call it from now on, Tiger. It sounds better than Tigger anyway, I guess. So I added this indexed variable, this member, to this structure because I want to have the raw data of what pixels are set to in the palette, or sorry, what palette indexes are used by the image, right? Because what's happening is when Tiger is loading the PNG, it's going through this whole process of taking this data that's been compressed and mapping it to an uncompressed image, right, which is the full width and height and all the colors. And part of what's happening when programs refer to indexed PNGs, what they're really referring to is yet another sort of compression. So they're saying, okay, within the file, I have a palette of however many colors, right, times n, however many colors that is. In the case of what we're doing, it's 64. And then I have this image data, and rather than specifying the RGB values, I'm just going to specify what palette value it is, right? So I'm going to say this is palette 1, this is palette 2, this is palette 7, right? that's no different than how the NES stores its images in the format that it uses, except that it goes one step further and it stores things in a very, very small format, because knowing that you can only have 4 colors in your palette for the NES, it says, okay, you have 2 different bytes that are used to represent essentially different bits in the tile. It's here. Let's talk about that for a second. So the way that it works is you have 1, 2, 3, 4, 5, 6, 7, 8. Can I copy and paste here? I'm increasing my is there a way to select in this? No? Alright, well, so there's 2 completely different bytes. 1, 2, 3, 4, 5, 6, 7, 8. Right, so there are 2 bytes that represent the pixels, right, in one row. Now, normally you'd say, oh, well, I'll just use 1 byte and it represents my palette value, right, for one of these colors in the 4 color palette. But Nintendo realized we could do it more efficiently, where we say, if we do it this way, we've got this first byte in this first bit in each byte. The 2 of those bits can represent all the possible values, right? Because if they're both 0, then the value is 0. It's the index 0. If one is 1, then it becomes the first. If the other is 1, it's the second. And then if they're both 1, it's the final palette value. Because realistically, all it's doing is, if this is binary, you have 0, 0, 1, 1, 0, 1, 1, right? So you get your 4 possible color values. And that's 8 pixels that it's doing it in 2 bytes. And so then it does that for all of the rows in that tile, to store it in that really sort of small compressed format. And it's somewhat easier than I think probably a little bit easier than trying to do that in a way where you're storing, 2 bits here and 2 bits here and 2 bits here and 2 bits here and another 2, where you've got to deal with the 2 bits together. It's actually easier at a low level to just pull the 1 bit off at a time, and deal with it that way. At least that's my understanding. So, same idea. This is a little bit less efficient because it has to be able to handle up to 256 colors. We're only dealing with 64, but Tiger didn't support storing the what they called the depalletized version of the image. So in this call here, it does the DPalette, where it converts the paletted index into the RGB value that needs to be used to display it on screen. I added this to the call so that it's actually storing the raw palette value. And the nice thing about that is, because it's just the 64-bit colors and the way that everything is arranged, the colors in the image and the palette correspond to the actual colors on the NES. So we don't have to do any weird mapping or conversions. So that's nice too. All right, so yeah, so what we were saying is, here we're going to iterate over the entire indexed image and set the appropriate bits in this color map. All right, so how, let's see, how would we do that? So based on the value, we want to shift 1 the appropriate number of times. So it's almost like we just want to do color map or equals 1 shifted by the palette value. That seems reasonable, but I always mess this kind of stuff up without actually seeing it, just because it can confuse me. So let's take a look at it here. So we've got the color map, and we've got image indexed J, which is 45. So we're going to shift 1 45 times, and then it's going to bitwise OR that onto color map, and we get 8192. And if we go to Windows Calculator and just confirm that, 8192, let's see, so 4, 8, 12. That doesn't seem right. Is it 1, 4, 5, 6, 7, 8, 9, 10, 11? No, that's not right. So did I mess up 1 shifted index J? Is that really 8192? It says it's an unsigned int64. So it should be able to represent that correctly. So that's good. That's the hex value. So it's not anywhere near where we want it to be. Index J. I feel like this is what I'm talking about when I say this stuff confuses me. And it's not because I don't understand how it works in principle. It's just that I tend to make stupid mistakes. I mean, if we were to do, let's do it this way, right? If we were to do color map or equals 1 shifted 63 times, right? I mean, this is going to be a huge number. But that should work, because that should give us something that is still within the range of possibility to represent for a 64-bit value, but it did not. Is it not I mean, the long let's take a look, because there's no point in me speculating about this. I thought long on Windows was, I mean, there's also the, I could have used the, maybe it's better if I use the underscore int64. Let's see. Wow, their search is so bad. This should not be taking any time. Let's do the opposite search. Let's search for N64. And see if it gives a list of the types, fundamental types. Here we go. That's what I was looking for. So a long is larger than an unsigned long object. Well, that doesn't tell me how many bits it is. It just tells me it's longer. So long is 8 bytes, which should be capable of representing that. Okay, let's try, let's just do this. Let's just change it to be unsigned int64. Let's see if that works differently. color map is 0. Still not. Oh, wait. I wonder, is it because 1 is not. So the compiler unsigned int 64.1. Let's see if this is the compiler doing something that I don't want it to do. Yes. Okay. So let me take a look at these warnings for a second here and see what it was complaining about. So this is that, that's that, and then, yeah, okay. All right, so why did this work? Well, the reason it worked, and this is one of those annoying things about types and why some people don't like strongly typed languages, or C, or C++ for that matter, is that, let's go back to what we had originally. So on the surface, this looks fine, right? I'm saying take 1 and shift it by 63 bits, and you, but you could see that the value we were getting was 0, and you could go, well, why? I mean, color map is 64 bits. It should be able to hold that, right? The last bit should get set to 1. The problem is that the compiler is saying, oh, I've got an integer, it's 1, and I'm going to shift it by 63 bits. So it's going to generate some code that's going to shift it by 63 bits. The issue with that is that integers, just plain integers, are only 32 bits, and so it's going to actually shift it off the end. And we can actually see that if we go to, let's see if I remember how to do this, and we can see some interesting stuff here. Where is the disassembler? Other windows, show me the disassembly. Do I right? Oh, you know, I think you can actually right click. No? Again, not something that I do every day, but I know, I remember you being able to do that. Other windows. Did they take it out? That would be surprising. Let's see. Am I just missing it? I can see the call hierarchy. I can see snippets. I can do source control stuff. Application Insight. Let's do a quick search because I could swear, and I want to show this just because it's interesting. Visual Studio 2017 switch to assembly. I gotta be more specific than that. I know, let's see. Yeah, go to disassembly. Where is that? That's what I want. Am I just missing it? Windows. Yeah, here it is. No, it's not. Why? Why aren't you showing me that? Those are the options. Debug, Windows, registers. I can see the registers. Graphics, stop, terminate, other debug targets, profiler. Well, I'll be damned. Where? Show diagnostic tools. I don't know why. Show source code. Is it gonna? Sorry I'm spending so much time on this. I do think it's valuable to look at the difference here. Yeah, where is that? Go to disassembly. Or is that something that's only available in like Visual Studio Pro now? Debug windows. To display the disassembly window on the debug menu window, click. I did that. Right click disassembly window. View data in debugger. Control Alt D. No, that's document outline. You lied to me. Document outline. Who wants that? Sorry I'm taking so much time on this. I wanted to show you the difference between how the code gets generated depending on what you're telling the compiler to do. And I can find this option here where I can look at this, but I can't actually see. I can't actually make it show the disassembly for some weird reason. And I used to be able to, I thought, just like click on it, or there was just a menu that brought it up, and it's just not. It's not here. If I can, or maybe I'm just missing it. Yeah, this doesn't really help me. Let me stop here for a second. Let's see. Is it like a project setting now that you have to turn on? I mean, obviously we'd be able to see that it works because, you know, it works. It made it do what we wanted, but kind of weird that that's hidden. Or just buried. Anyway, wasted enough time on that. Sorry, we'll find that for next time maybe. But so basically what it's doing is it's treating that as a 32-bit value, and then shifting it off. And then so you lose that one when you do the shift. You have to tell it, hey compiler, this is actually an unsigned 64. And then when it does the shift, it's going to do it on a 64-bit register where it can actually show you the, it can actually contain the 64 bits properly. And if I were to put that into the calculator, assuming that it doesn't explode, yeah, so it doesn't like that because it's just too big. We can do it with our other values because that'll work, but we got to do the same trick here. We got to say, hey, this one, it's actually an unsigned, UN64, right? We'll use our type, and now when we shift the bit and save it in color, yeah. So it would be nice if we could confirm that that is really what we wanted to do. Well, you know what we can do? We can switch to hex. That'll give us at least some sense that we're getting somewhere that we want to be. And then we can confirm that with each of these. So for the flyby, which is what I believe I selected, the first row, yeah, the first row of colors, if you look at it here, let me just zoom in. Oh, Windows, you're so disappointing all around. Sure. Can I zoom in Paint? Will it let me? Great. So that you can see the first row is the same color. So we're going to get the same color, the same bit set over and over again. So what we should get when we emerge out of that loop is we should see that there should only be 4 bits set. So we have 1, 2, and 4. 1 shifted 0 times should be 1, so we should have, let's see, 1, 2, 4. I feel like we should have, unless it's only using 3 colors. It's possible it's only using 3 colors. It's not particularly complex. But you can see it set some of these colors in the value here. It'd be nice if we could see it as a binary so we could actually see the bits that were set. We can maybe find something really quick online that will convert that for us so we can visually see. But if we choose the ship, same deal. If we look and we go to, oh, see, that's actually smaller. Maybe we can put that into the calculator and look at the bits. Yeah. All right. So we have that bit 1, 2, 3, 4. So we've got 4 bits set, which is exactly what we would expect because the ship has 4 colors set. So this is like perfect. This is exactly what we want because now what we can do is we just keep shifting bits off to count them and see how many colors we have in the image. And if we get more than 4, we can throw up a warning that that image has too many colors and can't be represented, at least in our simple model right now, of what the NES can represent. So if now we click on this, we should get a whole bunch of bits set. Yeah, you can see already that it's got way more color complexity in this. And I'm simply going based on the number of values here that are set across the entire 64-bit range. You can see it was way more sparse with the other images here. What we'll do is we'll add an unnecessary printf here so we can flip back and forth more easily. So you see how that's much more sparse. As we select, so that's good. That means that my idea worked, which is good. I hadn't thought about that before the stream. It just kind of came to me here, so that's cool. That's a good way of checking it. So now the next thing we want to do is we want to actually count the number of colors, right? So we want to see, now that we got this color map created, let's shift off all the bits. So for int j equals 264, j greater than equal to 0, plus j. Color count. So color count is basically we take color map and we add 1. Right? We just want the value of the first bit, and if it's 1, it'll add to this. Otherwise, it'll be 0, and we add 0 unnecessarily somewhat, but that's fine. And then we want to say color map shift right by 1. And we're just going to shift off that bit and check the next one. And we're just going to keep doing that. And then we say if color count is greater than or equal to 4, let's say max color exceeded equals true, which means we need to define max color exceeded. We can set that to false here. When we load the image, we want to reset that here. Oops, we don't want to recreate it. We just want to set it to be false. And then let's do this only if the image is selected and not null. We're going to say GUI label give it an ID of that, and then we say we can do it right above the image, I think. So we'll do 180 0 this image exceeds the number of supported colors on the NES. It might be too long, but so we're good here, hopefully. What happened? Why aren't you selecting? Oh. This image, no, it doesn't. All right, so something is wrong. Let's see. So if the item is selected. Oh, well, we don't have to check all the colors. Once we've exceeded the color count, we're good. Oh, dummy. I want to decrement J, not increment it. So basically the reason it was taking so long is that it was incrementing J until it overflowed. All right. So, all right, the text message is still wrong. I think I want to move all of this stuff down also. It's a little bit too close to the border for my taste of the window. So that's 20, and that's 20, and then we can make that 10. Let's see how that looks. Yeah, I mean that's fine. Let's see now why it thinks the color count is too high. Color count is 0. And we select the ship, which we know shouldn't. Oh, 1, 2, 3. No, that's okay. So that's 4. So it's going to do and 1. So color here. Let's even look at this color map and 1. Right? That's 1. So it's going to add to color count. So that's fine. Then it's going to shift it. Then it's going to get 0. And you can see that it's shifting the values over here. Color count. So we're so far so good. That 4 will then become a 2, and then a 1. Oh, why did that become a 9? Oh, because of the position of the bit, right? Yeah, of course. Sorry, so that's shifting things here. We don't need this anymore. So J is, what is the value of J? How far is it saying? We're at 36. Oh, you know why? I'm dumb. That's why. Because it's got to exceed 4. It can be 4. All right. So now, ship, if we select that. Why is it, there we go. Is it it's still, really? It's not triggering that. So max color exceeded equals false. Oh, am I not? Of course I'm not. Well, that helps. If you don't set the flag properly, of course it's going to draw it every time. Okay. So that's good. Yes, that's what I wanted. This image exceeds the number of supported colors on the NES. And then if we click on the flyby, yeah. So it's for that, for those, it's properly cool. So that's good. It's interesting. I wonder what that lag is all about, or that non-clicking. Is it some sort of performance thing? What is... Like, I'm clicking on ship, but it's not actually selecting it. Oh, is it not? Oh. So it seems like if I... The clicking on the items is... Well, I'll work on that off stream. That's just a minor thing related to the way that the clicking is happening. Okay, so cool. So we're actually counting the colors now, and we're seeing how many we've got here. We could even say how many colors it is. What I want to do is I want to move that color palette over and out of the way, and then we also need to get rid of that selected color, because that was just for testing to make sure that the color palette was actually working. It's not even using a real control. It's just filling the rectangle over the rendered GUI. So let's move our color selection palette over to the right. Let's say 700, 600, I don't know. I mean, I was going to say we could probably figure out what would be a good size. We might just want to put it on the bottom here, actually, and then make that anchored properly. Let's do that. I think that's probably a better idea. So let's see. So the image draws itself at 180. So let's say it's at 180. And then the list itself is 700 pixels tall. So let's put this at just short of, that might actually be pretty close. I was going to say we want to put it just short of the bottom. Oh, but see, that's actually too big. Well, that might be an extreme case where we don't really care. And we wouldn't be working on, at least in this view, we wouldn't be working on... My thinking is that for this, when you select a PNG, you're going to see, all right, how many colors is it using? Is it using too many colors? Is it too big? And then you can use the color palette selector to choose the colors that you want to either draw with over the image, or maybe some sort of color mapping where you can say, just directly map those indexed colors potentially. So, I should just probably move that down. So this is probably like a more realistic size, and then move this down, and then like I said, we can do the anchoring. I won't do that on stream just because it's not particularly interesting to watch the anchoring stuff. It's pretty straightforward. It's just going based on the height of the window and the position of the control. You get a delta between whatever it is you're anchoring to, and then as you adjust the screen, it repositions it based on that delta. So that's pretty close. It looks like it's probably about 8 pixels off, if I had to guess. So it's pretty close. So let's say 592, just to see if that... Yeah, that looks like that was right. Yeah. So, okay, cool. So the good thing is we've got that working. Obviously, the images are drawing off screen. I'm okay with that right now. We have this warning here. Probably want to move that. Again, we're still just kind of piecing this all together. But let's go with trying to export this out, right? So I should be able to click on this export image and have it generate a generate a file that we can then include in our char ROM, potentially as is. I mean, again, this is like super simple we're doing right now, but you got to start somewhere, right? You got to get the basics working, and then you start figuring out, okay, so, you know, like with this ship, if you remember in the previous streams, what I've shown is that the actual char ROM for the ship is only half the ship, because then we flip it. So similarly, we would want to be able to do some sort of tile deduplication where we can say, actually, we don't need this other half. We create a sprite entity that would be a separate file in here that you click that says, okay, it's these tiles and this size, and you know, these other tiles are half are these, but flipped horizontally, and then you know, be able to do bounding boxes and stuff like that. But that's kind of where we're going right now. Right now, I just or in the future, I should say. Right now, I just want to again get this exporting. We've got some basic stuff going here, and then yeah, we'll start adding complexity to it. So when I click on export image, what I should be able to do is just really easily write a char file with the image encoded in the bit format for the NES, and we can even verify that in YYCHR before we try and get it into the ROM, the code. What I'm ultimately thinking for the tool is that it will, again, you'll be able to do things like choose your sprite, and you know, or choose your image. Say that this is a sprite, so you click on create sprite. It creates a sprite entity based on that image. You can do manipulations where you say, okay, it's this, you know, these tiles, or some of these tiles are repeated, so make them flipped, and here's the bounding box and all of this other stuff. And when it exports it to a binary file, it's exporting all of the material both in a combination of assembler and raw binary data. Because what you can do is you can say, so let's take a look at our code here, right? All of our code right now is hard-coded into here. So like we have our title screen. This might actually be a good thing to show. So like we have our title screen here, right? And this is just raw bytes that we've typed in by hand. Well, there's nothing stopping us from actually putting this content into a file. So this is a hex editor that I've used for, I don't know, forever. It's called Fred. I think I've literally used this since, I want to say like 2000. It's a super useful hex editor. And what we can do is we can take the content of this data that we manually typed in. I don't know, well, let's see how good it is. I don't know if it'll recognize, overwrite, and then you have to tell it to expand. Oh no, insert? Yeah, so it pasted it as text. So I used to use this. I was working on a project where I was writing out bytecode for an assembly language that I created myself. And it required a lot of byte manipulation in terms of the generated bytecode. And so I spent a lot of time looking at raw bytes in Fred to try and figure out why my assembly wasn't running correctly, why my code wasn't doing what I expected it to do, making sure that everything happening the way that I wanted it to. Paste coded binary values as paste code. Come on, man. That's not what I wanted to do. Paste with dialog. Insert. Well, let's do what I wanted to do. Let's see. I wouldn't be surprised if there's a way to do it in here. I just generally was, reading content. Let's see. Using special syntax. Oh, yeah, there's a special syntax, so maybe we could paste it that way. Yeah, but then I gotta convert. Let's see. So maybe Sublime Text will help me out here. So I can remove the dollar signs with the multi-line editing. Of course, that one doesn't have dollar sign. And then do the same thing here. So what I want to do is, rather than having this hard-coded into our assembly like this, I want to make this a combination of included assembly code and raw binary data. It's okay to make that. It just messes up the alignment. We'll just manually finish this off here. So that we can kind of do that as a proof of concept for what the tool will actually eventually export, right? So let's see, if I take this, well, so now once again we'll do the same thing, right? We'll do multi-line select, get rid of the commas because we don't want those for Fred. I don't know if it's going to mind the spaces, but that'll be easy enough to, if I had known we had to do this, I would have gotten rid of it when I got rid of the dollar signs too. And yes, I'm sure I could write some sort of complicated macro to do this for me. But I feel like I'd end up spending more time writing the macro to do this than just getting it done. Gotta pick your battles. So let's see, can I just now paste this in? Insert. No, but don't do it as text, bud. I want you to paste it as bytes. Clipboard format to use. Oh, I keep doing that. Insert. FE. It's still doing it as text. I thought I said not to do it as text, or did I? This is going to be annoying about this if I You're embarrassing me, Fred. I was talking about how good you are. To be fair, it's probably just me not doing this the right way. Yeah, why can't I just make you do that? Paste with dialog. Clipboard content. Paste how many? Paste coded binary values as text. That's gonna. I wish it wouldn't close that every time. so that doesn't help. So let's go back to that special syntax. We can add that in because that may be the key to all of this. Use special syntax. Byte, double range. Is it just, I thought it was just, yeah, so it's just you wrap it with hex like that. So what you say, like this. Let's just confirm that I'm not going to waste my time doing this. Because of the space. Oops, what? Insert. What the hell, man? I thought there was a way for you to do what I'm trying to do with the syntax. Is that only for special? Let's see. For OLED drag and drop. Okay, so that's taking all of that. If I do this, it's just taking it literally as the UTF text, and then it's actually moving it. Where's the help for this? That wasn't super helpful. Front of drag and drop and move data between even for other similar early apps, but when dropping in more than one format, you can choose which format. Moving or copying. Move data, choose a copy, overwrite, cut, copy, paste. Yeah, I know. Let's see. If paste coded binary values is unchecked, all data contains special syntax, so will not be written as the text. Yeah, well, so is it because it had the space in it? Is that? Let's try just one. Insert. I'm so confused by their help not being actually helpful. Overwrite. It should just literally be the value FE. If paste-coded binary values as text is unchecked, all data in the clipboard is considered to contain special syntax. So LD 150 will not be written as text, but double word. Is it because I don't have the proper syntax? Like, is it supposed to be, let's say, like that? Long hex FE. I mean, that would make, oh yeah, okay, so that makes sense. That was just, okay. Because it has no idea how big the data is. so it doesn't know if it's a 8-bit or, okay, so we need BH. So if I take this and I paste it and we insert it, it will, there we go. Okay, sorry about that. That was unnecessarily complex. BH. And then word wrap, where you turn on, go away. Can I do, so I only have to type that, yeah, that's much better. Sorry, I'm sure this is probably killing some of you to watch this and see me long-handing this, but oops, wrong. Doesn't preserve the buffer for multi-line. Okay, so we'll just get this there, and then we add the closing. Okay. Now we have all our bytes. Hopefully this will work. Insert, paste. Hooray. So the last byte is FF. Excellent. Same deal here, right? Paste, insert. Good. The only thing I just noticed is it looks like it's including a space. Oh yeah, because it's literally including the space. Of course it is. I knew it was going to do that. I knew it was laying me off too easy here. All right, so get rid of the spaces. Can I just space nothing? Not regex. And why can't I just do it in the selection? Because why? Because can you not do it in a selection? And you can. Okay, so find space, replace with nothing. Replace. No. Do it in. Fine. Seriously? Why are all my tools not helping me out here? Sublime text, replace only selection. Yeah. Hit replace all and voila, all instances. Yeah, but whole word, case sensitive, regular expression, use buffer. Wow, this is just here. Pain in my ass. Okay. Shall we proceed? None of my tools want to cooperate today with what I want to do. Alright, so that's better. Now we don't have those space characters in there. Okay. Okay. So, good. So what I've done is I've replaced all of that content in, finally, a binary file. So title screen.bin, right? And then what I want to do is hopefully title screen.inc. What did I call that label before I title screen? Okay. Right, so now, yeah, I know you can't find it. I want to do incbin title screen.bin. I also need to do title screen like that. So now title screen.include or .inc. So what we're saying is include this inc file. In that inc file, it's got a label where it incbins, includes a binary file, which is our title screen bin. So we go to build that. That builds because the label is now defined in this file, instead of it being hard-coded into what we have here. And hopefully this was going to give us, of course it didn't work exactly right. Why would it have done that? I'm sure it was just something that got mangled from all the manipulation I had to do to get it into a format that worked. So let's try real quick, see if we can power through this with some smart find and replace, now that we know what the final format is supposed to actually look like. So we do that, go into here, multi-line select, delete this garbage, good, okay, find and replace, dollar with byte hex colon, right, replace all, turn off word wrap because it's useless in this instance, then we want to replace comma space with close, and replace, and that is that. And that was much faster than last time, so hopefully that was bearable. So let's go back to this, and if I do a paste and I do an insert, I should get all my data. I do, although I don't see it ending with, oh, haha, because there was a flaw in my plan, and that flaw was that the final element doesn't have a comma or a space, so it did not do that right. Okay, that wasn't too bad though. Insert that. Okay, save that. Resave that over this. Yes. All right. Wait a minute. Why is there still? I thought I saw stuff that had brackets in it still. Why is that? reopen that file. What is this garbage? Why are you giving me some? Because of the new line? Is that what messed it up in the first place, maybe? Still. Oh, is it the capital letter? Seriously? This is not cool. You'd think it'd be okay knowing that lowercase and uppercase in the special syntax is the same for hex. Okay. Now we have, hopefully, the right bytes. And then we can go back to what I was doing, which was saying inc, and then title screen.inc. Build that. Include, sorry. Invalid input character. Okay. Oh. Did I save it over the include file? That's odd. Okay. Maybe in my haste to do this, I messed it up. Yeah, that would be what I did. Okay. I overwrite the include file, not the bin file. That's okay. Include. Really? Okay. Thought it let you open the file. That's the. Oh, I closed that folder. Include. Okay, so. Okay. That built. What was it? Control F1? That's better. Still looks like something's wrong. But anyway, that's not a fault in the it's not a fault in the way that I'm in terms of what I'm trying to do. It's a fault with the way that the data is encoded in the binary file. So I don't want to spend any more time on that. It looks overall it's got basically the right setup here. Up until this point something got messed up. That's fine. I can fix that by going back through the bytes. But the idea is still solid. So we from the tool will generate this include file, which will include any of the binary data and generate any of the labels that we need for actual use of, of the content that we export. So that's good. I'll just have to figure out why it doesn't like the format of the binary data. I'm sure it's something ridiculous that just didn't get copied over right. So let's go back to the tool here. What I'm looking to do is right now I just want to iterate through and write out the bits that represent the colors for the image that we have loaded, and then we can look at it in YYCHR and make sure that that raw binary file is good. So let's just really sort of quick and dirty do that so we can get that done here and then wrap it up for the night. So file is equal to open. I need need some stuff here. So we will, let's see, how do we want to do this? Just really, again, really quick and dirty. We'll actually prompt for file names or have a rule for how file names get generated in a minute. Or not in a minute, in the next stream. We'll have the tool doing that properly. Let's call this test.bin. And we are opening it for, now let's see, Microsoft does this a little differently than the Unix platforms. FCNTL, in that the flags are a little different, but we can create, truncate. I don't remember if I think truncate actually creates if it's non-existent, and only truncates if it's why does it keep bringing me to these lousy search results instead of just to the actual MSDN results that I want? Yeah, so trunk opens a file, truncates it, can be specified. Opens trunk used with create open. Okay, so I do need both. Or creates, yeah. Okay, cool. That's what I want. I want it to be write only, and then is there? Yeah, I want binary also, because we are writing some binary. And so we want to close that. And then what we want to do is we want to take the bits from, or the bytes from our image and write them out in the right format. So the way that works, again, is we want to say total bytes equals the selected image. Oh, we have the image width and height stored where those aren't local, right? Those are set when we select. Yeah, okay, cool. So those are okay. And again, we're doing this through the index, through the indexed values, because we want to write out the index value that would be used in the palette. Now, we haven't dealt with the palettes yet. We haven't done any of that stuff. That's okay. I just want to get the, oh, well, see, now that's potentially not going to work if the value is stored. So if the value is stored in the, that's going to throw a monkey wrench in what we're trying to do. If the value is stored, so the way that the value is being stored is it's being stored based on a palette that looks like this, right? So it might be that we're using only 4 colors, but the 4 colors don't map down to a specific palette yet. So maybe we're going to have to come back to this. Let's do this. Let's write the code as if the colors mapped properly to 0 through 3, and then we will fix this, or I'll fix this for next time. So the other thing we want to do, in addition to this, what I want to do is I want to look at do I want to do that there and put a warning, a similar warning? I'm wondering if I want to put a warning, similar warning to the exceeding the number of colors that the colors in the image haven't been palletized yet. I don't think we care about that as far as a warning because we should be doing that before we do the export. So again, let's go based on the assumption that this is going to be 4 bytes. They're going to be properly set to 4 bytes, and basically, or sorry, the 2 possible bits. And what we want to do, let me think about this here for a second. What we want to do is we want to take, so every sprite is essentially 16 bytes, or every 8, is that right? Every 8 by 8 is, no, every 8 by 8 is, yeah, every 8 by 8 is 16 bytes versus like 64 bytes for 64 pixels in an 8 by 8. But it's split into two separate, sets of 8 bytes. And how do we want to represent that? So when I think about it as kind of like left and right bytes. So because that's how they're essentially laid out in the file. If I'm remembering this right from some of my earlier experimentation with this. Oops, whoa, that was okay. Right, so what you're going to get is you're going to get 8 bytes here, and you're going to get 8 bytes here, and that together represents the 64 pixels of a single tile. And which byte is which in terms of bit ordering, we'll figure that out for next time. Right now I just kind of wanted to get working where we actually see something appear reasonably close to what we would expect in YYCHR, and then we'll go from there. So let's think about this. What's the simplest way to approach this? Oh, there's so many things that I'm thinking about now. So if the image is actually composed of multiple tiles, then this isn't going to work. So I think we actually maybe have to stop here, only because there are some other things that we haven't done, and the way that the colors are stored in the image, again, it's not being converted into the 0 through 3 value for the palette, and well, and then what else? And then the other issue is that then if it's bigger than 8 by 8, if it's bigger than 8 by 8 or a single tile, like the ship is, then you obviously have to write this tile, then this tile, then this tile, then this tile, and I wasn't expecting to deal with that right now at this late in the stream. So let's do this. Let's capture the palette information for the 4 colors used and remap the indexed value to represent the new sort of boiled down colors that would represent a 4-color palette, right? So we need our color 4-color palette here. We can initialize that to 0. Right, and so now, Okay, so now we have our color map, and what we can do is and so what we'll do is as we iterate through this and try to calculate how many colors we have, we can use that to also populate the palette that we have there. So, and that'll work nicely. Palette color count. Let's do this. If color map and 1 equals what color? So the color is actually, and this should be 63, not 64. So the color is actually going to be the index because, or no, the reverse of the index, or we're counting down. Does it make sense to count down? Maybe we just count up, and then we don't have to do this crazy inverting logic here for no reason. So say it's less than 64. We add, and then we say, okay, if it's, yeah, so for 0, then if it's set, then the value is 0 because that color was, yeah, okay, that looks good. And then, well, we need a semicolon, obviously. And then what we can do is we can create really quickly a palette control that can draw the 4-color palette that was generated when we iterated through this. So let's first take a look at our color palette and make sure that it actually does what we want to do. I'm just going to comment this out for now because we're not really at a place where we can do this. What's wrong with my comment? Comment what? Oh, that's weird. I don't know why the slash didn't make it in there. Oh, and now I have it running, so yeah. Okay, so if we look at, well, it's going to have nothing right now. Let's do that. We'll do it at the point that we actually select something. So we selected the ship, and if we look at the palette in memory, we should see 4 values. So we have 0, 0, 0D, 1, 0, and 2, 2. So let's go to the NESDev. I happen to have this open here. So we have 0, 0, 0D, which we shouldn't be using because it's considered a bad color to use. There are a lot of reasons. You can see that, oh, is that, wait, which one is there's one that says it's considered like sub-black, basically, blacker than black. 0D, yeah, so 0D shouldn't be used. And apparently it's because of the way that NTSC colors are rendered on TVs. It goes into a big explanation about it, but anyway, something to make note of. We could technically flip that, but to do eliminate any use of 0D from image. So we don't want to use that, but again, because we're just generating the palette right now for the purposes of being able to then convert this over to the format that we need for the game. 0D, we have 1, 0, which is that light gray, and then 2, 2, which should be the blue color. Yeah, so 2, 2, it's like a purplish blue. So that's good. That's actually, it looks like a reasonable palette that makes sense for that ship. Right, so if you look at the colors here, that looks pretty reasonable. And then so what we can do is we can now, real quick, we should be able to add a palette control. So like a smaller version of the color selector, right, that just allows you to look at the palette. We won't do any mouse clicks or anything like that right now. So let's do that right about here. Let me say void palette view unsigned int ID, unsigned int x, unsigned int y, palette. Alright, so same as always, we want to find if it exists in our context, and if not, we're going to create it. The background can be white, the X and Y, the height and the width are unimportant, and there is no anchor style to this yet. And add control node, current context node. We want to set the control type to palette view, which doesn't exist yet. Right, and we need to set the renderer to render palette view. Otherwise, we're not going to do any. So if we get it back from there, we're good. We don't need to do anything. We need the render call, render palette view. Here's our layer and our node. Oh, you know what we need to store in there, though? We do need to know what the palette colors are. So let's see. Struct palette data. It's just a 4-byte palette, and we got to put that into our union palette data. Palette data. And did I not create the? Yeah. Okay. So now render palette. Mem copy node palette data palette size of car times 4, right? So we're just literally copying the content of this palette data into this palette memory, and then when we go to render it, what did we say? We were doing 32 by 32 blocks for the color selector. I think they're 32 by 32. Color size. Oh, are they 416 palette size? 32 by 32. Okay, so for int is 0 to 4. Fill a rectangle, or that's not it. It's tiger fill. Layer node x plus I times 32, or shift 5, I guess, right? Node y 32 by 32. NES palette, and this would be node palette data palette I, right? That's it. So we're saying, okay, we're gonna go across the screen by 32 at a time for each of the 4. We're gonna look up the color in the NES palette lookup, and they're gonna be 32 by 32. We're gonna do that 4 times. That looks reasonable. So in here, we're going to do GUI palette view OX4102. I want to do it right above the main color selector. So let's say 550, and then color. No, it's just palette. right? So let's see how that goes. Cool. So that's our 4-color palette now. Now, it's not changing the 4-color palette because of the same stack around palette was corrupted. Interesting. We'll have to figure out why that is. That's never a good thing. But I won't do that right now. Well, maybe I will. But yeah, maybe we'll do that in a minute. So let's see. So that has to change in the same way that the image has to change because of the fact that it's caching the palette value. So should this be the same deal? So we'll say palette ID. It's kind of annoying. There's got to be a better way to do that. We'll figure that out at a later time. So every time we select that, we want to flip the bit of the palette ID to get it to change its ID so that it's invalidated. Cool. So we can see that it's changing the palette of the image that we're loading. If we select that, it's gonna show the 4 colors, but obviously this is way too big and the colors there are far too many. So that's good. I'm pretty reasonably happy with that. I'm curious to know what is causing the stack to get corrupted. Let's see. So am I doing this the wrong way? So that's the source, destination. Palette is 4 bytes. Oh, yeah. Yeah, that's not going to work. So let's do this. So the problem is that I've only allocated 4 bytes, but if there's a 5th color, it's not going to work. And so let's see. So if we're at this point and color count is already equal to 4, we want to say it's less than or equal to 4, right? Because we don't want it to try and set this. No, just less than 4. We don't want it to set this if we've already got our 4 colors. So what was happening was we would get more than 4 colors. It would overwrite the 5th bit on the palette, and that was a stack variable. So what was happening is that it would overwrite the value in the stack that came after this in memory, because we were exceeding the size of the array. So that's why Visual Studio was complaining. So hopefully that error should go away now, or that warning should go away now when we close. Yeah, so that's all that was. All right, so that's progress. So we've got our color map, and then basically what we need to do is go back through the indexed colors of the ship and remap. And that's actually pretty easy to do. Right? Because now that we've got the colors mapped and we know that we are in a good position with the number of colors we've got, and we don't want to do this if max color exceeded, because at that point it's kind of pointless. We know where it's not going to fit. We have to do some sort of color reduction process on it. We can now go in and say, all right, so if image, how do we do this? How do we do this? So, well, this is, okay, so I'm going to argue, well, I'm not going to argue with anybody. Nobody's here to argue with me. I'm gonna say that this is okay for now, but we can probably do this better. And I'll have to look back at this. But basically, what we're going to do is we're going to look at the colors in the palette, and if we find a match in the indexed values here, we're gonna swap it. What's bad about this is that for every pixel potentially we're doing 4 comparisons. Not that we're dealing with a huge amount of data or a huge amount of colors, but you know, with big enough image, especially if we're going to be doing things like maps in this tool, then you're going to get problems with performance when you're doing this process. And probably what we could do is, if there was some way, could probably combine some of this so that as you're doing the iteration through, you can be smart about how you're mapping things out. But for now, let's just kind of do it the naive way. It may not matter. It may be fast enough that we don't care about it for now. It's not like this part's going to run on the NES, so it may be good enough to do this. This is dumb and potentially slow. We should revisit this to make sure we do this better. All right, so okay, so we've got the image indexed J. We're comparing it against palette K. So if these values match, and they would, in the sense that the index value is going to match the palette value's index value, or to put it another way, this color that's in the indexed map has not been reduced to the 0 through 3 that this palette represents. So the colors will be completely the same, and what we want to do is, if they match, we say, okay, this is now actually going to just be K. So we're reducing the color down from one of 64 colors down to 1 of 4, right? And so when we come out of this, not there, we'll do that here, and we select flyby. If we look at the image and we look at the indexed colors, you can see now the values are all 1 through 3. The flyby is actually maybe not the better example to do this with, just because it's only using 3 colors. The ship is a better example. And if we go and look at the ship index values, you can see we're getting all the range. We're getting 0 through 3. So that's good. That's exactly what we want. Really wish... Oh, it is showing the disassembly now. Is that because we're on a breakpoint? That's weird. I wonder why it wasn't showing it before. We don't need the code bytes. Okay. So that's good. That's doing what I wanted to do. And real quick, before we wrap up, I want to show what I was talking about before. So I'll put it all up here so we don't have to deal with going through the code to demonstrate this. So if I have some value here, I say value equals 1 shifted 50 times, right? Hit a breakpoint there. if I go to the disassembly, so this XOR is zeroing out XMM 0, which is one of the I believe it's one of the SIMD registers that are used. So is this gonna now purposely like do the right thing that it should have done in the first place just to prove me wrong? Let's see what it does. No, it's getting a 0. So move LPD. What is that instruction? Let's take a look at that for a second. So if we go to the disassembly here, so XMM, let's show the registers. Here they are. How come you're not showing all the registers? SSE? Yeah, okay. So that XOR PS, I believe, is just, like I said, it's an XOR. And if you XOR the same value together, X8, X64, XOR PS. Yeah, so if you do two values that are the same bits with an XOR together, what you're going to get is you're going to get 0. So it's just zeroing that out. And then it's saying X-word pointer keyword value pointer. Well, that's interesting. Why move LPD? Move LPD X64. Move low packed double. So why is it moving? So it's just zeroing this. Oh, is the compile? So maybe the compiler is smart enough to know that that's not going to work. So it's just setting. Okay. So the compiler is basically optimizing this out. It's like, this isn't going to work. The value is going to be 0. So basically it's XORing the SIMD register, or the SSE register, I should say. I shouldn't say SIMD, because, well, I guess it's part of the same thing. But this XMMO register, to make it 0 and just storing it in value, because it's like, yeah, I don't know what to do with this. I'm just going to make value 0 because that's the result of this operation. Now, if I change this 1 to be typecast to an unsigned int64, right? If you remember, what happened when we ran this was that it worked, and I was trying to show with the disassembly last time why that was. So well, that's, oh, so the compiler is actually generating the constant. That's really interesting. So let's take a look at this with a smaller value, and you'll see what it's doing. So this is the fun stuff of the low-level x86 programming. So what's happening is, in this case, it's saying 1 shifted by 5 is 20 hex 32, right, in decimal, and it's just storing that in there. So the compiler is actually doing the math of converting this as a constant over to the 64-bit value and storing that into value. I wonder, let's see, value. I wonder if we can make that. Oh, no, well, I can't do that. Well, I could, but I don't want to. Large. Unsigned int large equals 50. Let's see if it'll actually generate the code to do the shift here. Yeah, so here what it's doing is it's storing the value of 1 into the EAX register. It's zeroing out EDX for use somewhere else, I guess. It's loading the count the CX register with the value 50, and then it's calling this all SHL, which I assume is probably just a procedure that will do a shift. Yeah, so what this is doing is it's just oh, that's interesting. So it actually calls assembly code to handle more than to handle larger shifts in x86 code or x64 code. So it's just calculating how to do that. Now I wonder if I take out this typecast, if this will result in the same kind of code. This will probably result in the same kind of code. I think that what we were experiencing was the compiler trying to be more efficient. Yeah, so okay, so this is good because this is a case where we actually still see a poor result. What we would see is if we go back to this, value is uninitialized and we should do the shift and it's oh, this actually, is this because it's less than 64 bits? So it doesn't have to call that. That's interesting. So all of that is because I was doing constant shift versus a shift by a variable. So the compiler was essentially trying to be smarter about it than actually calculating it. It was pre-calculating it and compiling it into the code, which is why it was giving the value of 0. That's interesting. Wasn't expecting it to do that. Anyway, so in this case, it actually still, without the without the cast, it's actually still doing the work of shifting, because it doesn't. I mean, I think probably in release mode, it would look at the large value and say, I know that this never changes, and change this to a pre-calculated value, because the release mode optimization is going to be more aggressive than the debug mode. But I mean, you can see it's just moving the value of large into ECX, and then it's calling shift left, which is what that is on the value in EAX, which gives you what you need, and then it moves that value into from EAX into value. And yeah, I mean, all of that is pretty much what I expected it to do initially, but it was just kind of interesting how that panned out. So anyway, that was a tangent based on what was happening before. I just wanted to, since we saw the disassembly showing up, I wanted to go through that. So yeah, so we're at this point now where we've got our images and it's showing the color palette. So not only is it showing the color palette, but now it's also converting the raw palette values down to the 2-bit color representation that we want to write out in this section here when you click on the export image button, which it's not doing yet because we had to do that conversion. So I'm going to leave it that for now. Anybody who's watching the stream, do you guys have any questions or anything? We'll resume with this next, well, not next, on Thursday, where we'll actually get that value, the images written out as tiles to a binary file that we can look at in YYCHR, and then start writing out the inc files like I have here for the title screen, which include the binary data that we write out, and we can start doing that for things like sprites and bounding boxes and stuff like that, where right now all of that is essentially hard-coded into our code here like this. We can now start exporting this stuff out to files that we can include as a whole for the project, so that we can now start moving data out of the project and have that be controlled by the game and the content that we're loading for the game. Fox Aquatus, thanks. I'm glad that they're helpful explanations, And thanks for watching. Anybody else before I wrap up for the night? I'm fading fast here. My coffee only barely cut it this time. All right, well, then I'm going to wrap up for the evening, and I will see you all on Thursday. Thanks for watching, and if you have any questions, as always, you can find me on Twitter at Clairvis. I post the recordings to YouTube so that they can be watched after the live stream and rewatched, and you can always post a comment there. I try to answer them pretty quickly. If it's a question, and I'm also on NintendoAge.com under on the Discord chat, so it's a great community there. Definitely, you should check it out if you're interested in NES programming. NESDev also is a great resource and a great community. Some really amazingly smart people there who know the NES inside and out. And like I said, yeah, I'll see you on Thursday. Thanks for watching. See you next time.